identify the set of scores that have the smallest standard deviation. And you'll see here that for parts A, B, C, and D, I've got 4 different sets of values to work with. Now, I want to point out that on the printout you don't have these number lines, and so that's not how the question was meant to appear. I've put these number lines here to help us visualize these numbers, because what we're not going to be able to do is we're not going to be able to actually calculate 4 different standard deviations and then find the smallest one. There's a couple of reasons for that. First of all, it's not something that we would want to do, because that's going to take a long time to get through. To go through the math for one multiple choice question, to go through the math for 4 different sets of numbers to find 4 different standard deviations and then identify the smallest, it's going to take way too much time up. Instead, we're going to just consider that the standard deviation is a measure of variability, and so we're going to look for the smallest amount of variability, or whichever set of numbers shows the least variation. You can think about variation as being equals to spread, how spread out the numbers are. So that's why I wanted to visualize this on a number line. I've got 2 number lines here because even though most of them will fit on the first number line, if you look at the values in A, B, and D, they'll all fit within or on the first number line. For C, my values are much too high to fit, and I didn't want to have one enormous number line that went up to 300, because it would be so tightly packed you wouldn't really be able to see what's going on here. So with the same scale, I just created a second number line. Now, you don't have to necessarily do this when you're writing a test or an exam. This is just sort of a visual guide as to what it is that I'm talking about here in terms of spread. So let's have a look at the values for A. So I've got 10. So there's my first value. I've got an 18, so 15, 16, 17, 18, and then 30, and 43. So 40, 41, 42, 43. So these are my values for A. So just to sort of highlight the spread, that's what I'm dealing with there. Okay, now for B, what I'm going to do is change the color up. And so B, those values are 2 and 12, 10, 11, 12, and 33, 30, 31, 32, 33, and 28. Okay, so 25, 26, 27, 28. All right, so a very similar amount of variation there, considering that variation or variability can be represented as spread in a set of numbers. What about C? I've got 283. I will give this a new number. So 283. That's 280, 1, 2, 3. That's my first number there. Actually, I think I have to bring this way up here to be able to see it properly. 284, that's just one step over. 285, again, that's just one step over. And 287, that's 2 steps over. Okay, so here it's a very tightly packed set of numbers. Even though they're very high numbers, they're up in the upper 200s, the numbers themselves are not very spread out. And then finally, my last set of numbers, 18, is where? 18 is 15, 20. So right there is 15, 16, 17, 18. And then I've got 111. I didn't even put that on here. I didn't realize. So sort of do dot, 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 dot. I know that this isn't exactly to scale, but let's say that 111, let's see, there's 80, 90, 100. It would be off the scale. So I'm just going to pretend that 111 is way out here, because I think this is pretty obvious. This is going to easily be the most spread out set of numbers. And then I've got a 18, and there's a 12, 10, 11, 12, and finally a 76. Okay, so this purple set of numbers from part D is by far, even though I don't exactly have this at the right spot here, you can see easily that the purple values are more spread out. So easily, D is the most spread out, and A and B are the red and the blue. It's the green one, C. These numbers have the smallest spread. They have the smallest amount of variation. Now, once again, you don't have to do this on a test. You could simply just look at the numbers themselves and see these numbers are only off by 1 or 2 points in each step, and so they're very tightly packed with each other. They tried to make this into a bit of a trick question by making the numbers themselves very large in order to mask the fact that they're very close together, but these numbers do have the smallest standard deviation because they have the smallest amount of spread.